Hello, my name is Andre Taborian. I'm presenting today on behalf of the project team 09 for the CMPS 253 course at AUB. The reason we decided to choose the PC Health project is that we believe that as a company grows, the management of its hardware infrastructure does not necessarily scale very well if it is not planned for. That is why we have decided to tackle the challenge of creating a management environment that simplifies the monitoring of large clusters of computers in an intuitive way. So, on today's agenda, we will first give a brief overview of the basic architecture of our project. Then, we'll talk a little bit about each component of this architecture and how it might look like from a software perspective. First, before getting into the specifics of PC Health, I would like to introduce my team. We are a group of two front-end developers, Marwan and Joseph, as well as two back-end engineers, Luai and I. Finally, we can start talking about the architecture of our product. This will be part 1. Let's introduce the basic terminology that we use internally to describe all the parties that have a stake in the application. First, there's the leaf. A leaf is one of the computers that needs to be monitored. Then there's the NIT. It stands for non-IT. This is the person that owns or operates a leaf. Then we have the root. The root is a server receiving data from the leaves. And for all terms and purposes, in our case, this will be the cloud, a server in the cloud. And finally, we have the admin, and this would be you, the person monitoring the network of computers. Now that we know this, we need to determine how each party will interact with each other. As we said previously, we have a group of leaves that we need to monitor. We also have the root that is represented by a cloud. These two entities communicate with each other to share health information, and maybe, eventually, they may also communicate to change some settings in the leaves. In the end, we have an admin, represented by a Google Chrome icon, since he will interact with the rest of the system through a web app. Let's remember, as is traditional with the web app, the admin will enter into a client-server relationship with the root. Now, we're getting into the interesting stuff, the Leaf app. I will now introduce perhaps the most important requirements that we evaluated for the whole application. First and foremost, in the Leaf app, we have its weight. We have determined that a Leaf app would need to be a background process and very lightweight. The reason for this is that we do not want to affect the important work that a NEET might be doing on his own machine. Then, we would like to have an event-based as well as a request-based reporting. What I mean by that is that the application needs to be able to report information triggered by an event, but the application also needs to be able to report information triggered by a request from the server. Finally, we have found that WMI is a great way to achieve the features that we would like to present to our customers. WMI stands for the Windows Management Instrumentation. And this is a Windows tool that we base our application around, and we will use it to get all kinds of system information such as CPU usage, memory usage, disk usage, so many things. Of course, we need a backend. Without a backend, we wouldn't be able to access all that information, let alone store it. That is why it's important to talk about it. And this is what we'll do in part 3. The backend. Let us first study the database and the storage side of this application. We have determined that because of the sheer diversity of data that a leaf might send, we would need to have a very flexible and scalable solution for our database. For that, we are thinking of approaching the problem from a polyglot approach. In addition to that, we should be able to store a huge amount of data for our application. The reason is that if we take just one leaf, and this particular leaf sent like 1 kilobyte of data per 5 seconds. If I have my calculations right, this would amount to a measly 17 point something megabytes per day. However, let us not forget that this application is being constructed for companies that have more than 1,000 computers. If this is the case, then for just a single company, we would need to allocate at least 17 gigabytes of data per day on the long run, which I think is kind of big. So that's why we thought we should be able to store a huge amount of data. In addition to that, we need to study the connection side of things. The application needs to be able to support a huge amount of parallel connections for the same reasons as we said previously. And these connections need to be full duplex and long-lived. That is why we have determined that the cloud is probably the best option to manage our application, something like AWS or Azure. Of course, without a user interface, there would be no real point in developing the backend as well as the Leaf app. So, to us, it is very important to have a great user interface. To do that, we have decided to provide a web application. Since we have not yet decided on the specifics of how it should work, I will not dwell too long on it. However, I will say one thing. We want it to look great, but we also want it to be very well organized. And this will play an essential role in giving a great user experience to the admins that decide to hopefully adopt our application. I would now like to conclude this presentation by showing a a couple of things. First, I would like to give you a rough timeline of what we're expecting to do over the next week. We will start by migrating from our proof of concept environment to our planned environment. We will then finalize our choices on the front end. Next, we will start developing our first user stories. And that is when we will be able to make a new presentation that we will post on YouTube. Also, I would like to point you to a link in the description below where you will be able to have a look at our proof of concept where we study the feasibility of the project. However, I would ask you to remember that any code you may see is still only part of our proof of concept and will not at all represent how the application may work in the future. I would like to thank you for attending this presentation. I will ask you to please like, share and subscribe. I will see you next time.